Before we open the AWS Console, I want to quickly show you what we are going to build. We will look at what a VPC is, the difference between public and private subnets, and how traffic moves in and out of the network. We will also look at the Internet Gateway, the NAT Gateway, and what a more production-ready design looks like. The idea is simple. Understand the design first, then build it step by step. This large box represents our VPC. You can think of a VPC as your own private network inside AWS. Inside the VPC, we have two availability zones. These are separate AWS locations within the same region. We use two zones because we do not want the whole system to depend on only one location. Inside each zone, we have a public subnet and a private subnet. The green areas are the public subnets. The blue areas are the private subnets. Public subnets are used for resources that need to connect directly to the internet. Private subnets are used for application servers and databases that should stay hidden from direct internet access. At the top, we have the Internet Gateway. That is what connects the VPC to the internet. We also have a NAT Gateway in the public subnet. The NAT Gateway allows a private server to go out to the internet, for example, to download updates, without giving that server a public IP address. So the simple idea is this. The Internet Gateway is for public internet access. The NAT Gateway is for private servers that need outbound internet access. And the route tables decide where the traffic goes. Now let us look at the public subnet. A subnet is not public just because we call it public. What makes it public is the route table. This route, 10.0.0.0/16 to local means. Traffic for resources inside the VPC stays inside the VPC. This route, 0.0.0.0/0 to the internet. Gateway means other traffic can go out to the internet. For this EC2 instance to receive traffic from the internet, it normally also needs a public IP address. Its security group must allow the correct port. For example, port 80 for a website or port 443 for HTTPS. And of course, the application must actually be running. So, when a public server is not working, check 4 things: the route table, the public IP, the security group, and the application. The main thing to remember is this. The route table is what makes the subnet public. Now let us look at the private subnet. This private EC2 instance does not have a public IP address. It also does not have a direct route to the Internet Gateway. That means someone on the internet cannot connect directly to it. But the server may still need internet access. For example, it may need to download updates or connect to an external API. That is where the NAT Gateway comes in. The private server sends its traffic to the NAT Gateway. The NAT Gateway then sends the traffic out through the Internet Gateway. The response comes back through the same path. So the server can connect out, but people on the internet cannot start a new connection directly to it. A simple way to think about it is this. The private server can make an outside call, but outside users cannot call it directly. That is the main job of the NAT Gateway. This is what the design looks like when we improve it for production. Instead of users connecting directly to one EC2 instance, they connect to an application load balancer. The load balancer then sends traffic to healthy application servers. The application servers stay inside private subnets. They do not need public IP addresses. We also place application servers in 2 availability zones. That way, if one server or one zone has a problem, the other side can continue working. The databases sit even deeper inside private database subnets. They should only accept traffic from the application servers. We also have one NAT gateway in each availability zone. That improves reliability. although it also increases cost. So the production design is split into 3 layers. The public layer receives traffic. The private application layer runs the application. The private database layer stores the data. This gives us better security, better availability, and a much cleaner design. First, this is the completed network inside AWS. I have one VPC using the address range 10.0.0.0/16. Inside the VPC, there are 4 subnets, 2 public subnets and 2 private subnets. These subnets are spread across 2 availability zones, which improves availability. Now I will show the route tables, because the routes are what actually make a subnet public or private. This is the public route table, the route 10.0.0.0/16 points to local, which allows resources inside the VPC to communicate with each other. The important route is 0.0.0.0/0, which points to the Internet Gateway. That means any traffic going outside the VPC is sent to the Internet. This route table is associated with the public subnets, so this is what makes them public. This is the private route table. It also has the local route for internal VPC communication, but notice the default route is different. Instead of pointing to the Internet Gateway, 0.0.0.0/0 points to the NAT Gateway. This means instances in the private subnet can start outbound internet connections, but the internet cannot directly connect back to them. This is the NAT Gateway used by the private route table. It is public, and it sits inside the public subnet. It also has the public elastic IP address, 35.177.213.7. Later, when the private server connects to the internet, this is the public IP address we expect to see. This is the public EC2 instance. It is inside the public subnet, and it has a public IPv4 address, 18.170.2.20.219. Because it has a public IP and its subnet routes traffic to the Internet Gateway, it can receive traffic from the internet. The route table alone is not enough. The security group must also allow the traffic. Here, the inbound rule allows TCP port 80, which is HTTP traffic. So the network path and the firewall rule are both in place for the public web server. Now I open the public IP address in the browser. The test page loads successfully. This proves that the public server is reachable from the internet through the Internet Gateway. The public route table, the public IP address, the security group, and the web server. This is the private EC2 instance. It has a private IPv4 address, but it does not have a public IPv4 address. That means users on the internet cannot directly connect to this server. This is the main purpose of placing it in a private subnet. Even though the private server has no public IP address, it can still connect out to the internet. I ran curl-https://checkip.amazonoz.com from the private instance using Systems Manager. The returned public IP is 35.177.213.7. That matches the NAT Gateway elastic IP we saw earlier. This proves the private server is reaching the internet through the NAT Gateway while still remaining private. We have now proved both traffic paths. The public server receives internet traffic through the Internet Gateway. The private server has no public IP address, but it can connect out through the NAT Gateway. So the public route table sends traffic to the Internet Gateway, while the private route table sends traffic to the NAT Gateway. That is the key difference between public and private subnets. The theory explains the design, and this practical test proves that the design works.